So I've been playing with this new AI IDE called Windsurf for the past few days. Even though this looks familiar like any other AI IDE, it does feel very different when you actually use it. One of the key things that Windsurf doing particularly well is the context awareness. If you ever use Cursor to implement some feature to existing projects, one thing you will quickly realize is that Cursor often didn't really understand the project structure very well. Even though you set up a project and ask it to build an app, it often has no idea about what type of project it is and where it should create the right project file. Not to mention, if you want to ask Cursor to add a new feature to your existing codebase, it almost guaranteed to fail because it generally didn't really understand the dependencies of different files. So how is the Windsurf going to be different? So this is a Windsurf interface. It looks pretty familiar like any other AI IDE. You can build any files, try to do things like autocomplete. But what's really magic is this cascade feature. So cascade, to some extent, you can consider that as like Cursor Composer. It is an agent that can create files, run commands, and understand your project structures. And it might look similar to any other chat with code-based interface. But once you try it, it does feel a little bit different, as it is really aware of the whole project structure, the environment it is in, much better. As a quick example, I have this Next.js project already set up with certain file structures. I can just prompt Windsurf Cascade to build out the web app, and without prompting it the current file structure, it will be able to create a file in the right places. For example, if I wanted to create a basic text-to-image platform, I can just take a documentation from Flux model that is hosted on Replicate, copy-paste the whole doc directly, and then add a simple prompt above the text-to-image AI model hosted on Replicate. Help me turn it into a web app using Next.js and Chassis. I already set up the project in my app folder. And you will see that before you implement any code, it will firstly try to analyze your project structure to understand where to create which files. It identified that the Next.js project and Chassis components are already set up. And next, it will also show this UI, ask me for approval to run certain terminal commands. So it is able to actually run command directly. And if I click accept, it will run command and get a result. If there's no error, it will continue. But you can imagine if the command line return error, it will also be able to self-reflect and fix the issue. If you check the project folder on the left, everything has been created in the right place as expected. And you will know that there's a components folder already, so all the new components will go under that folder. And if we open this app, it is also running too. And apart from those project structure, it actually keeps track and understand all the change that human is making alongside the AI. For example, I can go to this component and change the name of this function to be text to image form instead and save this. And obviously this will cause errors since all the variable name is wrong. But I can actually just go to Cascade and say continue without giving any prompt. It actually understands and notices that the component name has been changed from image generated form to text to image form. Then it starts refactoring the whole code base to making sure everything has been updated and using the new name. And it also proposed update the file name to reflect the change as well. So this was really big aha moment for me. And that made me realize why it is important to build an IDE instead of just a Visual Studio plugin. Because now they can understand so much better what the user is doing and get a lot more contextual information, like the change they make, which file they are on at the moment, or even have sandbox environment to get direct feedback from the console. And another thing I experienced while I was using Windsurf is that there's one time I got a bug in the application that I'm trying to build, and then ask Windsurf to fix it. Then what I observe is that it actually starts reflect and iterate its own solution. So it generates a fix at the beginning, and then later it said, let me try another approach since the previous one might still have issues. So it tried another version, but after that it tried again. It says, let me try one final approach that should work more reliably. And in the end, it does fix the issue. So this was really interesting because quite often when I use other platforms like Cursor or Copilot, while you're debugging, many times it feels like it is just running in circle and try to do the same thing again and again and not fixing the issue. But this ability to actually reflect and think about different ways it can solve the problem can probably dramatically improve the result and output. Though it's a bit mystery to me about when this will be triggered and how does it decide there are actually still improvements and iterations it should do. But this behavior definitely feels very agentic and smart. So as I mentioned before, even though this Windsurf UI looks very familiar, behind the scenes there are a lot of work goes into improve the code quality as well as the context awareness. And to understand why Windsurf is doing so much better in terms of context awareness, I reached out to the Coding and Windsurf team to understand what their secret sauce are. And they share a lot of interesting thoughts of how does Windsurf actually work behind the scenes. But before I show you those insights and interview clips, I know many of you just getting started learning how to code. And one question I got asked a lot is whether it is still needed to learn coding. If so, what does a roadmap actually look like? And that is why I want to introduce you to this free ebook dated by Google's principal analytics lead and data scientist, Sunday Scarlett, where she wrote down all the secret tips and methodologies that she used to learn coding with platforms like ChatGPT and design a personalized learning roadmap. It covers all the fundamentals and basics of coding, like how do you choose the right coding language to start with for your purpose, best practice prompt for different coding scenarios like debugging and optimizing the code, as well as detailed roadmap of how to master Python in just 4 months, with a purpose-built custom GPT that contain a lot of learning resource, and detailed video tutorial showcase step-by-step of her workflow. So I definitely recommend you go take a look if you're just getting started with your coding journey. I have put the link in the description below for you to download for free. And thanks HubSpot for sharing this awesome material for free. Now let's get back to Windsurf. And here is the interview clips between me and Coding founding engineer Ansho, where he shared a lot of interesting learnings and thoughts about how Windsurf is building this context-aware IDE.
The way I always kind of explain Cascade is we've given the AI access to 3 things, right? Knowledge, tools, and the human actions. And I think there was kind of research along each of those 3 things that we realized that we were at a depth within each that combining them actually made sense to do larger and larger tasks. So on the knowledge side, we've been investing a lot of time into building what we like to call a context awareness engine, right? Systems that can truly actually take large code bases, AST parse them, embed them, index them, combine full repository awareness with the code structure. So we've been spending a lot of time building those systems that are orthogonal from the LLMs themselves. That's one part of the Codium story. We support over 1,000 enterprises, including a number of the Fortune 500. And the only way that we're truly able to give a company of that kind of complexity of code is if we've done a really good job at understanding their code base. That's the first axis. So that there's kind of constant research there that we've already always been doing, been powering the Codium extension so far. But then the tools and the human actions part, I think, were more recent. And I think that's when things came together. On the tool side, we recognized there were some like tools like, okay, make an edit to a file or add a file or grep or list a directory. Like these were kind of obvious tools that we wanted to give the AI. I don't think these are necessarily groundbreaking kind of ideas. But we'd also built other tools as well. And one of them was actually covered by the press a few months ago. It was this idea that embedding-based retrieval had some fundamental limitations, right? If you have a lot of code, false positive rates for embedding-based retrieval simply means that the number of false positives increase, and if you have a lot of garbage coming in, you have garbage coming out. And so we'd come up with a new way of actually leveraging compute to actually massively parallelize a bunch of LLMs running at once across a large amount of compute to essentially retrieve more relevant snippets at a much higher accuracy than any embedding-based method, right? If we just go back to embedding-based methods, right? You're taking raw code snippets, you're putting them into a lower dimensional space. By definition, you're losing some of the nuance of the original raw text. That's just part of it. So any embedding-based system, there is a fundamental limit to it on kind of the accuracy and how low your false positive rates can get. But what if you flip the question a little? What if you say, okay, what if we can actually just, instead of doing embedding-based search, because you do embedding-based search because it's fast, what if we actually trained a proprietary LLM that was really good at asking the simple question, is this snippet of code relevant to the query that I'm asking? It doesn't have to be a very large model, but it's like a purpose-built model that's really good at that one question. And then you take that model, you parallelize essentially thousands of those calls across a ton of compute for a really burst period of time, then essentially you can get a really much more higher quality score on the relevance of each code snippet to the query at hand. Actually captures the full nuance of the raw text. And then we've essentially figured out by using that as a signal and using that as an ability to do search, it is significantly outperforms any embedding-based state-of-the-art method possible. Yes, you're doing a trade-off of compute, but like we'll take that trade-off any day if that actually means it creates significantly better. So that was like some breakthroughs there. And then on the human actions part, I think it was just really trying to figure out what's the right granularity of like a trajectory. Are we able to actually pick up on what the developer is editing or where the developer is going into the editor and how they're navigating a directory or doing commands in the terminal, and understanding the granularity that was required there to really get a true picture of what a developer was doing at all times. And I think that was the third reason, and that was the most recent one, where it's like, okay, we really do want access and control over the editor because we want to see what a developer is doing. Because if we can understand what the developer is doing, we have a much, much better chance of understanding what their intent is, and then therefore giving them relevant results. So
Mm,
there's a lot of stuff. I can't say it was just like, ah, yes, we have one magic bullet
yeah.
that unlocked everything, right? It's like multiple years of actual work that came together that made it really clear that if we just developed our own surface, our own UX, or our own IDE, we could expose this in a pretty magical way.
And to best demonstrate how can you get the most out of Windsurf, let's build a real application together. And while I was looking for use case to build, I saw this tweet from Greg Eisenberg, where there's a microservice called bank statement converter. Basically just do one thing, taking the PDF and convert them into Excel. But this simple application itself is generating more than 30K revenue per month. And this is really interesting because extract structured data from PDFs is a job that large language model is really good at. And there are so many different niches you can potentially build, like for accounting firms, lawyers, marketing agencies. Many of them spend hundreds of hours every month to do this data entry and converting job. So I use Windsurf to build this PDF to Excel converter, where you can drop any sort of different type of PDF files and define all the data points that you care about. And it will do the rest of work to extract information and convert them into Excel file that people can download. With this one, you can easily tweak into specific vertical solutions that you know well, and maybe get a smaller model to fine tune and drive down the cost. And I'm going to show you step by step how can you build this in Windsurf. So I'm going to set up a new project in GitHub so we can keep track of version. And firstly, I want to set up a Next.js project using Sass. And then I'm going to do cd converter, npx chassis and latest, add input select car label button, which is a list of common components we likely gonna need to use. And to build this PDF converter, the pipeline looks something like this. The app will take a bunch of different PDFs, and then we're gonna use llama parse, which is probably the best PDF to markdown converter we have on the market. It's basically a service that can take messy PDF files and extract information into Markdown, which is a format that large language model is really good at reading. You might wonder, why do we need a special PDF converter? Well, that's because PDF is really complex and messy. There are all sorts of different structures like tables or diagrams and even equations. And sometimes the reading order is also different. You might have PDF file that contain text that has to be read in certain order to make sense. So there are a whole bunch of optimization need to be done to making sure large language model can actually read the PDF file properly. And this is where llama parser is really good at. So we're gonna use llama parse to actually extract structured markdown text from messy PDFs. And then we're gonna feed this data to large language model that supports structured data extraction, like GPT-4o model. Then we can flatten those data into an Excel file. And as we mentioned before, we're gonna use Next.js as a framework. And if you're not familiar with the front-end development, Next.js is a type of front-end framework. Instead of building from scratch, they will provide a lot of components built-in already with specific project structure. And Chassis and Tailwind is just the UI component and CSS library to make your app looks better. And we're also gonna use npm and npx, they are like the package manager, to install third-party libraries. So let's get started. So I will create an instructions folder inside this project folder, and then create an instructions.md file. If you ever watch my other AI coding videos, you will know my process normally starts from defining a product requirement doc to align with AI so that whatever it is building is going to deliver the result I want. And the common structure normally look like a project overview to indicate what does the project do, the core functionality that I wanted to deliver, the relevant documentations, and important implementation notes to cover common mistakes that AI model make, as well as the current file structure. But one really good thing about Windsurf is that it is really good at understanding your project structure. So I actually don't need to do this hack anymore to include the current file structure because Windsurf just gets it, but the rest of content still remain relevant. And I have asked Windsurf team to confirm that as well, and this is their recommendation about how much information you should give upfront. So in our case, I will give this project overview that your goal is to build a Next.js app that allow users to upload multiple PDF files and use OpenAI structure output to extract information and convert to Excel file. You will be using Next.js 14, Chassis, Tailwind, Lucid Icon. And then I'm going to write down the core functionalities in my mind. For this app, there are 4 key components. One is we need to allow users to upload a file and define the data points that they want to extract. Then we're going to use the llama parse to extract the text and send to OpenAI to process those data. And in the end, convert it into an Excel file so people can download. And I normally tend to specify a very detailed behavior that I want. So here is what I put for the file upload and schema definition. So the user should be able to upload one or more PDF files, and they should be able to define data point they want to extract. It can be either individual fields or it can be groups, which is like array of objects that they want to extract. And this could be useful for things like bank statement or invoice, where you might have a list of information with similar structure that you want to capture. And for each group, users can define multiple fields inside as well, or even other group to create those kind of nested structure. And there should be a button start extraction. And I also want to set a default schema to showcase how does this software works. So I'm just going to give a default value. And in the end, here I mentioned that it needs to be server-side file processing. Basically, in front-end environment, each function you can do on the client side or server side. And server-side actions are good for tasks that require either security, data preloading, and file processing typically is something handled on server side. But majority of doc here, you can see basically just split out the requirements of what kind of feature that you want to build. Then for text extraction, I would say use Llama for the PDF text extraction. And again, it is server side. And for each file, combine all the document chunks for complete text, making sure return the full text. So this is something I noticed when I was using Llama parse before, because it will break down the whole PDF into multiple different chunks. And quite often, large language model didn't know that and only extract the first chunk, which means we're not getting the full PDF data. So I'm just adding this instruction here. And this text extraction should happen immediately after user upload the file to the UI instead of waiting for the button to click, so that we can make this process a bit faster and strictly following Llama parser documentation as code implementation example. So this is actually pretty important because Llama parser is a fairly new package. So model like Cloud or GPT-4o didn't really have much knowledge about how to use that. And typically what I do is I will just go to their documentation and copy paste the file here into my instruction doc. And I will making sure the name here is the same, because this I believe will actually help Windsurf to pay attention to the relevant parts of documents if the identifier here is the same. And after each file uploaded, it should be displayed as an item on the page so that users can click to preview the text extracted and they can keep adding files. And this should be a server-side processing only. And then the data processing. So after user click on the start extraction button, the data should be sent to OpenAI to process all the files, use OpenAI structure output for information extraction, and strictly following the documentation that we attach for OpenAI structured data output. And I will basically do the same thing to find a relevant code example that I can put in. For this specific one, OpenAI provided an example for structured data extraction. So I'm going to copy and paste in. And one thing I will put in here is also a note that making sure you use GPT-4o model and Zod for defining data structure. This is something I found when I was using Cursor. It almost guarantee fail with this OpenAI functionality because structure output is a fairly new feature that OpenAI released, and large language model didn't have that knowledge. When I'm using Cursor, it wasn't that great in terms of fetching the right code example inside the documentations. So it tends to implement in the old-fashioned way. And this is where you will see Windsurf that is really good at. And last part, we will also put documentation for file download. So combine all the data processed from multiple different files into one Excel. When they're nest structure, flatten them. And we should have proper error handling and enable Excel file download. And we also want to implement temporal file cleanup, because otherwise all the Excel file uploaded will just keep piling up. And that's pretty much it. The last thing I will do is that I will also include some important implementation notes. So in my AI coding workflow, I tend to keep track about a list of common errors here so that it's less likely it will make those mistakes. So with this one, it's pretty much ready to go. We can start let Windsurf to implement this app for us. I'm going to open Cascade, which is their coding agent in Windsurf. And then give it instruction. I want to build a Next.js app for user to upload PDF files and convert into Excel. Implement strictly based on this instruction that I give. I've set up the project already in this folder. Now let's build this first feature, which is file upload and schema definition. So there are a few things that you will see happening. If firstly, go inside the instruction file and then look up the relevant chunk. You can see which lines of code it actually looks through. Then you will also check what kind of components already exist in this project to making sure it is creating file in the right place. And what you will see here is that compared with Cursor Composer, After every step here, it can reflect a bit of what has been done before and then move on to the next step. And after this is done, you will also see something cool. In the code it generated, it used a few UI component library that we haven't installed yet. So it will generate the terminal command and ask us for approval. And if I just accept here, it will run the command line and move on to the next step. And this is really good because if your command line has some errors, it will also get as feedback so they can iterate and decide next step based on that. And let's try to run this. I will open terminal and then do npm run dev. Cool, so you can see this app is already built where I can upload files and can also define the specific data point that I care about. I can give a name, data type, the description here. If it's group, I can define information further as well. Great, so now I'm going to move to next step. Let's do step 2. And what happened next is it actually will go back to the instruction.md and look for the relevant information as part of context. And here notice that I need to install new libraries. So I will just accept that. Okay, so it finished, but it got an error. This error basically means that we haven't really added this dialog component from the chassis in. You can actually copy paste this in, and then it should be able to run the right command for you as well. But one thing to note is that at default, I think Cloud 3.5 is still using the old syntax, which is chassis and UI, and that will cause issues. So just making sure you add special instruction like this if you are using chassis and into the documentations. And what's really cool here is that because of this error, it also kind of reflects to say, oh, we need to check if other components that are required also install, and also look up the file doc to double check. Now, next two things we need to do based on the previous instruction is one is add a llama parser API key. Another is we need to create a folder inside the project root for uploaded files. So you can either just create a folder here for uploads directly, but you can also ask Windsurf to do this for you if you need. But I'll just create it directly here. And we also need to get llama parse API. You will create account on cloud.llamaindex.ai and then go to API keys, create new API keys here, and go to .env, paste your API key. So now we can refresh the page and give it a try. I'll upload this example PDF files. And once finished, there will be a view text button. If you click on that, you can see that the text has been extracted properly into Markdown file based on the original invoice PDF. Great, so now we can move to the next step. Let's do the step 3. And this is the part that I'm very interested in because, as I mentioned before, Cloud 3.5 has no idea about the latest structured output functionality. But you can see here in the Windsurf, the first thing it does is go to the relevant part of instruction, so it understands what's the latest syntax. Then it decides I need to install this OpenAI and Zod components, which is brilliant. That means it probably will implement in the right way. And then it will also try to use the chassis table. And what's brilliant about this is Windsurf somehow just remember those things a lot better and using the right syntax. And this will lead to much less errors, as you can see. All right, this functionality is done. All we need to do is just adding the OpenAI API key here in the .env file as well. Then we can try to run this. Go back, upload that file. And I just want to go quickly double check if it is implemented in the right way. So if I go to process data, you can see that it is using the right model and using exactly the right format that we asked to. And as a result, it showed us the table that we were looking for. So this is brilliant. I'm just going to ask it to do the last part, which is file download. And again, it will ask me to install this package. All right, so this part is done as well. We can go back to the application, upload the file, and then do the extraction. And once the data is extracted, you can see this download Excel file button. If I click on that, the result is showing in a proper Excel table. So this whole functionality is done already. As you can see, Windsurf did a really good job in terms of extracting and referencing to the latest doc, because both llama parse and the OpenAI structure output are not part of the large language model's knowledge, but it was able to reference to the right doc that I put in here. And last bit, I just want to do some quick UI touch up because now the style looks a bit kind of boring. And one thing I did learn from our community member Garrett in the AI Builder Club is that we can use v0.dev themes to control much better UI. For example, if you go to v0.dev/themes, you can click on theme to clone theme and playing with different styles on the left. You can even get AI to generate a special theme that you want. But for me, I kind of want to use this kind of Windows 98 type of style. And once you finish, you can copy code. and just paste those code into your Next.js project one by one. So I will paste this CSS file, which is a global CSS, paste it in, and then the fonts file in the layout.ts, which is under your app folder, and then the tailwind config, which should be in your root folder. And now you can try to run this. Okay, looks like we got some arrows that need to define the font weight. So you can just paste this arrow message in. And one really cool thing about Windsurf is that you can see that it actually knows what kind of modification you made recently without prompting it, so that it has more context and are able to fix those things directly for you. Cool. So we got this kind of Windows 98 style UI here. And another thing I do kind of curious to try out is that how good Windsurf is in terms of understanding your existing project structure and adding new feature to it. So I'll just start a new cascade, and I assume it probably didn't have a context or past chat history to understand where we create which file. So I'm going to just give instruction without any context, makes the app a lot more mobile friendly, and I want to display upload file UI and schema definition UI side by side, and make the start extraction button sticky at the bottom with primary color Windows blue. So you can see what it does is that it firstly analyze, it look into our page.tsx, which is the main file, try to analyze the file and understand what all the different components available there, and then try to identify where the right place to implement those changes. And if I go back to the application, you can say just transform the UI for me without me prompting it at all. And it is fully functional as well. So that's pretty much it. If you are interested in how to use V0 Sim and how to build UI part a lot better, Garrett actually did a course inside our AI Builder Club. And if you don't know what AI Builder Club is, it is a community that we're building where we dive deeper into all sorts of different AI coding and agent building courses with a step-by-step tutorial and code examples. And most importantly, we have this group of top AI builders who might already experience the problem that you are facing with. So you can just come and ask questions too. So feel free to click on the link in the description below to join this AI Build Club. I hope you enjoyed this video. So this is pretty much how we can use Windsurf to create applications. As you can see, just making the agent much more context aware, even though it is still not type of platform where you can just go give one single instruction and it will work out everything for you. But the code quality is much better. And I'm very excited about what type of interesting tips and tricks you guys start finding using Windsurf. So please comment below for sharing any interesting insights you have. Thank you, and I see you next time.